Okay, so now let's look at an example. Suppose the mean monthly rent for 10 randomly selected apartments is $980. Okay, let's assume that monthly rents are normally distributed, right, with a standard deviation of $280. Let's construct the 90% and 95% confidence intervals for the average monthly rent. Okay, so let's go ahead and specify what we know, right? We know that we have a sample with 10 observations, so n is equal to 10, right? The mean of that sample, x bar, is 980, okay? And then we have the underlying variable here, which is monthly rent, which is a normal variable with a standard deviation of $280. So sigma x here is going to be equal to 280. Okay. So the general formula that we're going to be using is x bar plus minus z sub alpha over 2 times sigma x divided by root n. Okay. So let's first look at the 90% confidence interval. If we apply that formula to calculate a 90% confidence interval, we're going to have 980 plus minus 1.645, right, times 280 divided by the square root of 10. Well, okay, let's hold on. Let's take a step back, okay? So we're looking at the 90% confidence interval, right? That means that our confidence level is 90%, right? Our confidence coefficient is 0.9, which gives us alpha of 0.1. So alpha over 2 is going to be equal to 0.05. Okay. Now we know that when alpha over 2 is 0.05, z sub alpha over 2 is going to be equal to 1.645. Okay. Now let's see how we obtain that value, right? So if you draw the standard normal distribution, then if this is z sub alpha over 2, then this is 0.05, right? So the idea is we want to find the z-score such that the area to the right of it is 0.05. Now remember that the table gives us the area to the left of a z-score, okay? So in order to use a table, we need to find the area, the unshaded area in this figure. And this unshaded area is just going to be equal to 1 minus 0.05, right, which is 0.95. Okay, so now the idea is we will want to go into the standard normal table, the z table, look for 0.95 in the interior, and then trace it out horizontally and vertically to get the z-score. Okay, so let's go ahead and do that. So if you go to the z table, we want to look for 0.95 in the interior, right? So we have here 0.9495, and then the next entry is 0.9505, right? So 0.95 falls between these two numbers. In fact, 0.95 is exactly the midpoint between these two numbers. So when it's the midpoint, the convention is we want to average the two z-scores, okay? So when the area to the left of the of a z-score is 0.9495, we get a z value of 1.64, right? When the area to the left of a z-score is 0.9505, the z-score is 1.65, okay? And so if we average those, is 1.64 plus 1.65 divided by 2, that gives you 1.645, okay? If you go to the table I gave you earlier, that's exactly what we got, okay? So z sub alpha over 2 is 1.645, right? And that's how we got this, okay? So now let's go ahead and apply the formula, right? The formula says that to calculate the confidence interval, we take x bar, which is 980, plus minus z sub alpha over 2, in this case is 1.645, times sigma x, in this case is 280, divided by the square root of the sample size, which is the square root of 10, okay? Now if you do the math, this is 980 plus minus 1.645 times 88.54, okay, which is equal to 980 plus minus 145.65, okay? And so the 90% confidence interval is the interval from 834.35 to 1,125.65, okay? Now, what's the interpretation of that interval? Okay, the interpretation is that we are 90% confident that the population mean is between 834 $834.35, so $834.35, and $1,125.65. Okay, so that's the interpretation of the result. Okay, so now let's go ahead and look at the 95% confidence interval. Okay, now when we look at the 95% confidence interval, the confidence level is 95%. That gives us a confidence coefficient of 0.95. So alpha is going to be 1 minus 0.95, which is 0.05, right? And so alpha over 2 is going to be equal to 0.025. Okay? That gives a z sub alpha over 2 of 1.96. Okay? Let's see how we found 1.96. Again, you want to draw the standard normal distribution. Okay, and we're interested in a z value such that the area to the right of it is alpha over 2, which in this case is 0.025. Okay, that means that the area to the left of the z-squared is 1 minus 0.025, which is 0.975. So again, the idea is you go into the standard normal table, look for 0.975 in the interior, and trace it horizontally and vertically to get the z-score. Okay, so let's go ahead and do that. Okay, so here's my standard normal table. If you look for 0.975 in the table, it's right here, right? So if you trace it horizontally, you get 1.9. If you trace it vertically, you get 0.06. And so z sub alpha over 2 is going to be 1.96. Okay? And that value was given to you in this table. Okay? So this is 1.96. And so now let's go ahead and apply the formula, right? So the 95% confidence interval is going to be 980 plus minus 1.96 times 280 divided by the square root of 10. Okay, that gives us 980 plus minus 1.96 times 88.54. Right, so I'm gonna skip the math here, but you should get an interval from 806.46 to 1153.54. Okay, so what's the interpretation? The interpretation of that interval is that we are 95% confident that the population mean is between $806.46 and $1,153.54. Okay? Okay. Now recall that the 90% confidence interval is the interval from 834.35 to 1125.65. Okay, and the 95% confidence interval is what we just calculated, which is from 806.46 to 1153.54. Okay, now if you put these numbers on a number line, okay, so if you put these numbers on the number line, then this is your 90% confidence interval, right? And this is your 95% confidence interval. Okay? Now the 90% confidence interval is a smaller interval than the 95% confidence interval. Okay? So essentially we have a trade-off here, right? So the trade-off here is between the size of the interval and the confidence level. Okay, so the smaller the interval, the less confident we are. Right, that it contains our population mean. Okay, right, now this kind of makes sense intuitively, right? For example, we could say that the mean monthly rent is between $800 and $810. How confident are we? The answer is we're not very confident, right? Okay, because it's such a small interval, right? On the other hand, we can say that the mean rent is between $0 and $10 million. Okay, how confident are we? Super confident. Okay, that the mean is gonna fall in that interval. So this is a trade-off that we face, which is an important consideration when we build confidence intervals.